Hi everyone, welcome back to the series about mathematics behind AI. Last video we ended with the question, we have this formula speed that depends on distance and time. If we don't want to fix neither of the time and the distance, can we still represent this as a function? And the answer is of course yes, and I hope you've thought about it, because we actually seen all the ingredients, because we actually seen that functions something very general. It's the relation between one set and another set. And this one set, well, I can of course take the product of some sets. Because what can I do? I can just look at the function, the product of all the strict positive reals with itself, and I can go to the real numbers. And now any element in here which looks like a tuple, and I will denote this by x and t, and I just map this to x divided by t. And now, of course, the v as a relation of this thing, so if I would say the graph of v, these are of course, I am working in the graph of v, a relation is a subset of the product of this guy with this guy. So I'm actually working in this set. So elements are of the form x, t, and v. It's a three-tuple for which it holds that v equals x over t. And of course, you have to say x and t are strictly positive. V is a real number. So of course you can draw this. It's a bit harder to draw because it's in 3 dimensions. If this is my x, this is my t, and this is my v, then this goes a bit like something like this. This is just a sketch. This is not so important. Again, there's some nice software that easily allows you to make these plots, but that's not the key issue here. So think about any other formula you know, maybe from a physics course, maybe with some more parameters. You can always try to write this as a function. And this is exactly what we will be doing when we're going to construct at the end of the series a machine learning application. We can look, for example, at functions from n-dimensional space, r to the power n. Remember, this is just the product of r with itself n times. I can go to an m-dimensional space. M can be bigger than n, can be smaller than n, can be equal than n. It doesn't really matter. And well, what's an element here? It's an n-tuple, so I know an element looks like this, and this is just mapped to something f of this n-tuple. So let's give a concrete example. I could actually go from r squared, from the plane to 3-dimensional space. And every tuple xy, well, I'm just going to map this to, for example, 5xy minus 1, y squared minus pi, and 4. Right? And this is interesting, actually, if at some point you will have a course on linear algebra, what you will actually study is you will study functions from Rn to Rm, which are linear, which means that if you sum two elements, whatever that means in Rn, I haven't explained that, but you can, this equals the sum of the function values. And if you multiply with a certain scalar, lambda x, this is lambda f of x. These are linear maps, and you will see that these correspond to actually matrices of size m times n. But this is just, you can forget about this. This is a bit what you might do in a course of linear algebra. What we will actually consider often is functions just from Rn to the power Rm. What type of functions? Well, we're gonna impose some more conditions in the next two videos. Ciao.